Hello students, in this video we are going to study that root 2 is an irrational number. That is, we have to prove that root 2. What is root 2 actually? For example, you take a right angled triangle. Okay, now let us say the right angled triangle, one angle is 90 degree. Let us say A, B and C, and this value is 1 unit, 1 centimeter, and this is 1 centimeter. Then what will be this value? We know Pythagoras theorem. Using Pythagoras theorem, we say AC square is equal to AB square plus BC square, which is equal to 1 square plus 1 square. That is 1 square plus 1, 1 plus 1 is equal to 2. That is AC square. So AC is equal to under root 2. So you will find that the hypotenuse is root 2. So root 2, what is this actually? Is it a rational number or irrational number? Now for that we should know what do you mean by a rational number. A rational number can be expressed as P upon Q, as a ratio, as a fraction, P upon Q. And a condition is there, Q should not be equal to 0. That means the denominator cannot become 0. And P and Q are any two integers. For example, so this is a rational number. I can call this as a rational number R. Take for example 1 upon 2. What is 1 upon 2? 0.5. So this is a rational number and it is terminating. Now I take for example 3 divided by 7. Okay, now 3 divided by 7. So it will not go, put a point here, 0. So 4 times it will become 28, remainder 2. 20, 2 times it will go 14. 6, 60, it will go 8 times 56. Again 4, 40. Okay, that is 5 times it will go, that is 35. Again 5, 50, it will go 7 times. Okay, that is 49. And again you get 10, 1 time it will go, that is 7. Again remainder 3. Till then, if you see, it is remaining same. The answer is supposed to be 0.428571. And again 30 comes after this 1. So again 428571. So this much is repeating. This many digits are repeating. So this is also a non-terminating or repeating rational number. Or you take another simple number. For example, I can say 7 by 3. Right? So 7 you take and 3 you divide. 2 times 6 that is 1. So 10, put a point here. 3 times again 9, 1, 10. So 3, 3, 3. It is recurring. Okay. So I can write 2.33 bar, or I can write 2.3 bar after point. If I want one digit, I just put after point that bar. It is recurring. So a rational number can terminate or it can recur. Right? And the condition is P by Q, that is a form, right? A fraction, and Q should not be equal to 0. This is basically a rational number. Now we have to prove that root 2, this root 2 is irrational. That means it is not going to be terminating, that means about terminating, recurring. We have different issues for that. Now we have to prove that. Yes. Now I will tell you what is the generally root 2 value, and then you will understand what are we going to do about that. Okay. We usually take root 2 value to be equal to 1.414 for all practical purposes, right? But it is going so many, it's non-terminating. Now in such cases, okay, it's not going to repeat also. We have to prove that this root 2 is irrational. We are going to prove it by the method of contradiction, right? This is called proof by contradiction. Now what do you mean by contradiction? See, we all know that sun rises in the east. Sun rises in the east. But I cannot prove it, let us say. What I do, sun rises in the west. What I do, I put a statement, sun rises in the west. And what you will say? No, you will contradict, you will contrary, your statement is wrong, you will prove that. So, that is what we are going to do here by the proof of contradiction. What are we going to do? First we will say root 2 is a rational number. Okay, we will say it is a rational number. If it is a rational number, I have to prove according to that this is going to be a rational number. If it is not a rational number, naturally it is irrational. This is called proof by contradiction. So how do we proceed for this? Let me erase this part. Okay. Yeah, just a second please. Yeah. Yes. Now I have taken the statement. When you say root 2 is rational, I can write it in the form of P upon Q, which is equal to root 2, where P and Q are integers. Okay, any integer, right? Negative or can be positive. Fine, that I have taken, but the condition is Q is not equal to 0. P and comma Q are integers, right? This is what I have taken. Now, from here I can say, let me erase, you need to be very clear. Let me write steps very carefully. Okay? Yeah. Let P by Q is equal to root 2, where P comma Q are integers, and Q is not equal